This lesson will focus on graphing, and we're going to take standard form equations that are of quadratics, and we're going to transfer them into vertex form. So we're going to use the method of completing the square, and we're going to use it in a context of doing it with the graph. So let's start off by looking at a problem like this and how we would graph it. So you have your graphing calculator, but using the technique that we know, we're going to take and make this x equals the opposite of b over 2a to get the vertex, which is negative 8 over 2 times 1, which is negative 8 over 2, which is negative 4. So my x value at the vertex is negative 4. My y value then would be negative 4 squared plus 8 times negative 4 plus 12. And that's going to be 16 plus negative 32, 8 times negative 4, plus 12. So you get 16, negative 16 plus 12. That gives me negative 4. So my vertex is going to be at negative 4, negative 4. Negative 4 for x, negative 4 for y. So you go negative 4, negative 4. And if we were to look at the table for this, it would make sense, because if you look at the table on this one, notice that the negative 4 and negative 4 are right in the middle of the symmetry going on. So the other points are wrapped around it because of that symmetry. So what this graph would look like to actually graph it would go here, here for these points that we just did, and then here and here. And so we'd have this graph and this half and this half of the parabola. So that's how we would graph it. Notice that we found the vertex and then we looked at the table to get the other values. To review a little bit, let's take that same equation, set it equal to 0 to see if about solving the equation. What we should do is we should get this negative 2, and we should get this this other value here at negative 6. Let's change that one here. So this other one should be here at negative 6 to give that symmetry. Okay, so let's take a look at how that happens with completing the square. Now, if you recall, the first step is to subtract 12 from both sides. So you get it equal to negative 12. And then we're going to take half of this linear term, half of the 8 coefficient, and we're going to square it and add it to both sides. So when we take half of 8, we get 4. Squared is a 16, so we add 16 to both sides. Over here, we're going to get this equal to a positive 4. And over here, this is going to factor into the x plus 4, the quantity squared. This factors into x plus 4, x plus 4. It's that half of the 8, that plus 4 that goes in there. Now to solve this, once we get it into this perfect square form, we can solve by perfect squares by taking the square root of both sides. So x plus 4 is going to equal plus or minus the square root of 4 is 2. And then we subtract 4 from both sides. So x equals negative 4 plus 2 or negative 4 minus 2. So this negative 4 plus 2 would give me a negative 2. Negative 4 minus 2 would be negative 6. So those two answers would be, again, these two values where the graph actually crosses the x-axis there. All right, so that's reviewing completing the square to solve. This is reviewing how we know how to graph. Let's go ahead and talk about vertex form. This is standard form. We want to talk about vertex form. Now, vertex form, remember, the general form for vertex form looks like this. Y equals a times the quantity x minus h, the quantity squared, plus k. Now, we actually know from doing this problem every piece of information that we need from this. So an informal method of writing it into vertex form is to look at the original formula here and to go ahead and steal from it what the a is. Remember, this is ax squared plus bx plus c is the general form of standard form. So the a is the number in front of the x squared. So this, the a is going to equal 1 for this problem. And then we've got the h and the k. That's just the values at the vertex. So my h is going to equal negative 4, and my k is going to equal negative 4. So my vertex form of this is going to equal y equals 1 times x minus a negative 4 will be x plus 4 squared. Remember, it always tends to be the opposite on the inside of the parentheses. And then minus 4 because it's plus k out there. And I'll just rewrite it without the 1. Y equals x plus 4, the quantity squared, minus 4. So this is an informal way of getting the vertex form from the standard form. Find the vertex, use your A, put the values in, and you get your vertex form. Now I do want to teach you a more formal way to do it. This is actually the steps for doing it using completing the square. So this process to convert it to vertex form, this is using completing the square. So it's going to be very similar to what we did for solving, but it's going to have some extra pieces to it. So be aware that some things are a little bit different for that. So let's look at these steps. The first step is going to be to group the variable terms together. The x squared term and the x term get grouped together. Then we're going to factor out if there's an a in front of the x squared, so you got to factor it out. You got to complete the square. And the way you do that is you balance the equation by adding to both sides of the equation. Add to the y side and add to the side that we're working with. And you got to make sure that if there's an a factored out in front of the parentheses, you got to multiply by it. So these are our steps for it. Let me show you, and then we simplify into vertex form. So let's go ahead and take this problem here. The first thing I want to do is to group together the x squared and the 10x. Now, if there's a number in front of the x squared, we're going to factor it out, and there isn't. So I'm going to leave a space after the y. I'm going to leave a space after the 10x because we're going to fill that in with adding something to both sides, and then we have the minus 4 out here. Now we complete the square just like we did before. We take half of this 10, square it, and add it to this here. Half of 10 is 5. 5 squared is 25. Whatever's in here, if there's a number out here, we have to multiply it. That's this extra step. Make sure you multiply it by the number a from step 2. Well, there's not a number in front of x squared, so all we have to do is add 25 to this other side. But it's to y rather than to a number like we did in completing the square for solving. So we have y plus 25 is equal to, now this is a perfect square. When we took half of it, we got 10. That's what goes in the parentheses here. And then we still have the minus 4. And now we simplify by subtracting 25 from both sides. So y equals x plus 5, the quantity squared, subtract 25 from 4, and negative 4, and you get negative 29. So my vertex here, notice that I've got it in vertex form. This is what I'm shooting for right here. My vertex is just the opposite of what's in there, negative 5, and the same as what's out here, negative 29. And there's my vertex. All right, let's do one now with a number that's actually in front of the x squared. So this one will be a little more difficult, so watch the extra step when it comes to what we add to both sides. So I'm going to rewrite this. I'm going to leave a space plus a space, and I'm going to factor out the 2 here. X squared minus 6x plus a space. Okay, so what I have here now is I just grouped these two together. So it's taking these two, grouping them together, factoring out the 2, and now I'm going to complete the square. Well, taking half of this negative 6 and then squaring it, half of negative 6 is equal to negative 3, but if you square it, you get a positive, so it's going to be a 9 that we add to this side. Now, what we add to the other side is not 9, because notice the balance on this side of the equation, we've got a balance on the other side of the equation. That's what you do in algebra, is balance on both sides of the equation. Notice that this 2 is actually 2 times 9 is what's really being added to this side. We're adding an 18 to this side, not just a 9. So whatever you put over here, this is going to be a 2 times 9, because you take the a, multiply it by that, and that's what you add. So I have a y plus 18 here equals 2 times, let me move that down just a little bit here because it's too close to that. So I'm going to have y plus 18 is equal to 2 times, and here I'm going to have x, half of the negative 6 was a negative 3, that's what goes in here as the squared. That's what this factors into, is x minus 3, plus the 15. And then what do I do last? Is I subtract the 18 from both sides to get rid of this number over with the y. So my vertex form would be 2 times x minus 3, the quantity squared, and then 15 minus the 18 is negative 3. So my vertex here, this is my actual answer because I'm converting it to vertex form. My vertex is the opposite of this one, so it's 3, and the same as out here, negative 3, my vertex. So what we did was we reviewed a little bit about how we find the vertex from standard form, and then we looked at completing the square. So 2 different activities, and now we combine them. We want to take something that's in standard form, and we want to complete the square on it in order to get the formula into vertex form. So we now have this formula where the vertex is easy to find. So we have 2 methods now for finding the vertex. Using the opposite of b over 2a for the x value in the standard form, or converting using completing the square, a formula into vertex form.